Hi everyone, it's Mrs. Griffin, the Unit 8 Lesson 14 video on area of a sector. Please do the opening exercise on your own. So, for starters, one idea that we need to talk about is that the arc length of any circle and its radius is in a specific ratio. There's a relationship between them. Okay, and that relationship is that they would equal theta. And the reason for that is this formula we talked about yesterday. If you were to divide by r on both sides here, then you would get the equation solved for theta to be that theta is equal to the arc length divided by the radius. Okay, S for arc length, R for radius. And that is also, you can be written as a ratio. So theta, the angle, the central angle, is equal to the length of the arc divided by the radius. Okay, now, moving on for what we did today, we have what's called a sector. A sector is a section of a circle enclosed by two radii and the arc between them. So it would be this portion in here. Essentially, it's like a slice of pizza. Okay, and we're going to be finding the area of these sectors. So there are two ways to do this. The first is to take the whole area of the entire circle and multiply it by a fraction. Since the sector is only a portion of the full circle, you would take whatever the angle is for that sector over 360 if you're using degrees, or that angle over 2 pi if you're using radians, and you're just multiplying by it. So you're saying, for example, if it was a 60-degree section, you would say it'd be 60 out of 360 times whatever the area was of the whole circle. So it's 63/60ths. Okay, or you can also make a proportion. All right, and your proportion is going to use the concept of part over whole. All right, so if we are in degrees, then you're going to put the area of the sector, which is what you're looking for, over the total area. And that would equal the number of degrees out of 360 for the circle. Okay, if you're in radians, then it's similar. However, instead of being out of a total of 360, it's out of 2 pi because 2 pi is equivalent to 360. Okay, both ways will work. It really just depends on what you're given and how you want to do the problem. So for example, in number 1, if we want to find the exact area, the first thing we need to know no matter what is the area of the circle. So for a circle, it's pi r squared, which in this case the radius is 3, and so the area is 9 pi. Okay, if you're going to do it the first way that I showed, then you would take that 9 pi to find the area of the sector and multiply it by a fraction. And our current angle that we're talking about is in radians. So we would use the 2 pi on the bottom. So we would take our 5 pi over 3 and put it over 2 pi. Now a fraction in a fraction is when things start to get tricky. So we do want to be a little bit more careful on that. So what we would have to do here is multiply across. And doing that, we're multiplying this by the top of the top. And we're getting 45 pi times pi, or 45 pi squared, either way. Over 3, just for the top, it's still all over 2 pi. And then we would have to simplify this further. So 45 does divide by 3, which is nice, because now we can write that as 15 pi squared over 2 pi. And then one of these pi's would cancel with this one, and we would have 15 pi over 2, or 7.5 pi. And that's exact because we leave it in terms of pi. Okay, and it is an area, so we take our unit from radius, and it would be that unit squared. Okay, so that's version 1. Version 2 is to take this and create a proportion. So if you're going to do version 2, just move this up a little bit. Okay, you're going to take the area that you found at first, right here, and you're going to make a proportion. So you're doing part over whole equals part over whole. So the area of the sector is the part we're looking for out of the whole area. Okay, and then we have 5 pi over 3 radians out of the whole circle, which would be 2 pi. And you're going to cross multiply and solve. So 2 pi times x equals, and then the same kind of idea that we did up here, we have to multiply this all together. So the tops first. So 9 pi times 5 pi, which would be 45 pi squared, or 45 pi over 3. Okay, and if it divides nicely, you can divide it here. If it doesn't divide nicely, you could put this over 1 and then cross multiply a second time. That will work too. But this one did divide nicely. And then to get x by itself, we're dividing by 2 pi on both sides. These pi's cancel, and we would still get 7.5 pi, and it would still be centimeters squared. So either way will work. It really depends on which way you want to do this. Okay. For B, we are given the diameter is 6. That means that the radius is 3. So if you're doing it the first way, you're going to take your area, which is pi r squared, which is 9 pi, and you're going to multiply it by the 240 over 360. Okay, and so you're multiplying across the top. 9 times 240 is 2160. Keep the pi up there, and then divide by 360, which would be 6. So this would be 6 pi. Okay, and if you're making the proportion, you're doing the area over 9 pi equals 240 out of 360. Cross multiply that way, you're doing the exact same math, and then you're getting the exact same answer. It's just about how you want to format it. You'll still get the same thing. Okay. When you're doing this, what some people will do, because the radians in fractions can get tricky, you can also, if you wanted to, convert that first and then do either of those. So convert it to degrees will work too. So I'll show you that also. For C, it's up to you which way you want to do it. Pi r squared for your area. And then if you're multiplying by the fraction, it's 6 out of 2 pi because we're in radians. And you can do it all at once too. So 12 squared times 6 on top becomes 864 pi. And on the bottom it's just 2 pi. The pi's will cancel, and when you divide by 2, you'll get 432 centimeters squared. Or you can make the proportion. X out of a total area of pi r squared would be this part, 144 pi, equals, and it's 6 radians out of 2 pi. So that'll work too. You'll get the same answer. Like I was saying, what you can do is convert this if you wanted. So you can take your 2 pi over 5 radians and multiply by 180 over pi, and that becomes 360 pi over 5 pi. Cancel that, and 360 divided by 5 is 72 degrees. And then you can use that in either of the two ways. So that's another option for you. So either way will work. So if you do that, remember that radius is half of diameter, so pi r squared is 25 pi. That's the area of the whole circle. So for the sector, you can take that 25 pi and multiply it by 72 over 360. Or you can set up a proportion, the area out of the total 25 pi area equals 72 out of 360. And you'll get the same answer either way, because either way you have to do 72 times 25, which is 1800 pi, and then you would have to divide that by 360, which would be 5 pi and centimeters squared. Okay, so many different ways for you to do that. Okay, I'm going to try and choose what I feel to be the easiest on each of these. It's up to you. So we have to find the exact area of the sector. The radius is 10. That would mean that the whole circle has an area of 100 pi. Okay, so to find the area of the sector, where I'm going to take that 100 pi and multiply by 2 out of the 2 pi because we're in radians, and I get 200 pi over 2 pi which would be 100 centimeters squared. Okay. For this one, the radius is 3, so the whole circle has an area pi r squared of 9 pi. So the sector would have that 9 pi times 300 out of 360, because it's not the full circle, it's only 360ths of the circle. And then 9 times 300 is 2700. Keep the pi and then divide by 360, which would be 7.5 pi. Now this one says nearest tenth. Nearest anything means put pi in the calculator also. So we're actually going to do 7.5 times pi and round that to the nearest tenth, which would be 23.6 centimeters squared. And again, you use the same unit as the radius, just squared. Okay, for C here, the radius is 6, so the area for the whole circle is 36 pi. So for the sector, I would take that 36 pi and multiply it by the angle. I don't have the angle. Okay, I have the arc length instead, so I have to do some side work over here. You remember S equals r theta. I have S, and I have the radius, which is 6. I'm going to use that to find the angle. So divide by 6. So my angle is 5 pi over 6 radians. Okay, so I can put that 5 pi over 6 out of 2 pi because it's radians, or if I wanted to convert that 5 pi over 6 into degrees, I could do that also. So I could take the 5 pi over 6 and multiply by 180 over pi. 5 times 180 is 900, so this becomes 900 pi over 6 pi. The pi's cancel, and 900 divided by 6 is just 150 degrees. So if I wanted to, I could also put that in over 360. So either way, probably the simplest way for most people is to always use degrees and out of 360. And then 36 times 150 is 5400 pi. And then if you divide by 360, you'll get 15 pi. And this says in terms of pi, and it's centimeters squared because we found an area and we used the same unit that everything else used. Okay, so number 2D, we're finding the length of the arc, so that's your S equals r theta. Okay, defined by a sector. They're giving you the area this time and they're giving you the radius. So they're telling you that the area of the sector, which we usually take the original area and multiply it by the angle out of 360 or the angle out of 2 pi if I want radians. And they're telling us this part. So the 33 pi is the area. The radius is 6. We need to know what the angle is out of 2 pi. So I'm going to multiply everything across the top here. So 36 pi times theta, and then all on the bottom over 2 pi. And look here, the pi's cancel. 36 divided by 2 is 18. And then if I divide by 18 on both sides, that will get theta alone. So now I know that my angle is 33 pi over 18 radians. So I can finally use that to find my area of the sector, or the length of the arc. So the radius is 6. And now I can multiply that out. So 6 times 33 is 198 pi over 18. And if I divide that by 18, I'll get 11 pi. All right, for this one, the area of the shaded region, the whole circle has an area of 25 pi. There's 8 sections. Divide by 8, that makes 45 for each. Since there's 3 of them, we're going to multiply that by 135 out of 360. Multiply across the top for 3375, divide by 360, and you get your area. and it's inches squared.